Disclosure to promote the right to information. Whereas the Parliament of India has set out to provide a practical regime of right to information for citizens to secure access to information under the control of public authorities, in order to promote transparency and accountability in the working of every public authority, and whereas the attached publication of the Bureau of Indian Standards is of particular interest to the public, particularly disadvantaged communities and those engaged in the pursuit of education and knowledge, the attached public safety standard is made available to promote the timely dissemination of this information in an accurate manner to the public. 1 plus Mazdorki San Shakti Sangathan. The right to information, the right to life. 015 Jawaharlal Nehru. Step out from the old to the new is 10,262, 2009 Guidelines for Concrete Mix Design Proportioning Set 2, Cement and Concrete. $+ Satyanarayan Gang Aram Petroda. Invent a new India using knowledge. 0b Bharthariantiyatakam. Knowledge is such a treasure which cannot be stolen is 10,262, 2009 1 Li, Fakaj, L, QI5C11Y, Redefuit, Indian Standard Concrete Mix Proportioning, Guidelines, First Revision, ICS 91.100.30 Lilly 2009 Copyright CIS 2009 Bureau of Indian Standards Manak Bhavan. Bahadur Shah Zafar Marg New Delhi 110,002 Price Group 7 Cement and Concrete Sectional Committee, said to forward this Indian Standard, first revision, was adopted by the Bureau of Indian Standards, after the draft finalized by the Cement and Concrete Sectional Committee had been approved by the Civil Engineering Division Council. This standard was first published in 1982. In this first revision, the following major modifications have been made. A. The title of the standard has been modified as Concrete Mix Proportioning, Guidelines from the earlier title Recommended Guidelines for Concrete Mix Design. B. The applicability of the standard has been specified for ordinary and standard concrete grades only. C. Various requirements have been modified in line with the requirements of IS 456, 2000 Plain and Reinforced Concrete, Code of Practice, 4th Revision. D. The requirements for selection of water-cement ratio, water content, and estimation of coarse aggregate content and fine aggregate content have been reviewed and accordingly modified. Similarly, Auth-ER requirements such as trial mixes, illustrative examples, etc., have also been reviewed and modified. E. A new illustrative example of concrete mix proportioning using fly ash as one of the ingredients has been added. F. Considering that the air content in normal, non-air entrained, concrete is not of much significance in mix proportioning procedure and is also not a part of IS 456, 2000, the consideration of air content has been deleted. Concrete has become an indispensable construction material. According to the present state of the art, concrete has bypassed the stage of mere four-component system, that is, cement, water, coarse aggregate and fine aggregate. It can be a combination of far more number of ingredients, for example, a judicious combination of ingredients from as many as 10 materials. In the recent past, apart from the 4 ingredients mentioned above, fly ash, ground granulated blast furnace slag, silica fume, rice husk ash, metakaolin, and superplasticizer are 6 more ingredients which are generally used in concrete produced in practice as the situation demands. Hence, it is all the more essential at this juncture to have general guidelines on proportioning concrete mixes. The need has been further augmented by the importance given to proportioned concrete mixes according to IS 456, 2000. The objective of proportioning concrete mixes is to arrive at the most economical and practical combinations of different ingredients to produce concrete that will satisfy the performance requirements under specified conditions of USC. An integral part of concrete mix proportioning is the preparation of trial mixes and effect adjustments to such trials to strike a balance between the requirements of placement, that is, workability and strength, concomitantly satisfying durability requirements. Concrete has to be of satisfactory quality both in its fresh and hardened states. This task is best accomplished by trial mixes arrived at by the use of certain established relationships among different parameters and by analysis of data already generated, thereby providing a basis for judicious combination of all the ingredients involved. The basic principles which underline the proportioning of mixes are Abram's law for strength development and Leist's rule for making mix with adequate workability for placement in a dense state so as to enable the strength development as contemplated. From practical viewpoint, compressive strength is often taken as an index of acceptability. This does not necessarily satisfy the requirements of durability unless examined under specific context. Mix proportioning is generally carried out for a particular compressive strength requirements, ensuring that fresh concrete of the mix proportion to possess adequate workability for placement without segregation ad bleeding while attaining a dense state. In addition, the method has scope to consider the combination of wider spectrum of cement and mineral admixtures proposed to be used to meet the requirements of durability for the type of exposure conditions anticipated in service. Continued on third cover is 10262, 2009 Indian Standard Concrete Mix Proportioning, Guidelines, First Revision, 1 Scope 1.1 THISSTANDARD provides the Geudli NES for property 1 in concrete mis as pa the requirements using the concrete making materials including either supplementary materials identified for TH's purpose. The property oning is carried out to achieve specific characteristics at specified age, workability of IR/SH concrete and durability. Requirements. 1.2 This standard is applicable for ordinary and standard concrete grades only. 1.3 All requirements ORIS 456 in S0 far as the Y apply, shall be deemed to form part of the standard. 2 References. The following standards contain provisions, which through reference in THIS text. Instituted provisions of THIS standard, at the time of publication, the editions indicated were valid. All standards are subject to revision and parties to agreements based on THIS standard are encouraged to investigate the possibility of applying the most recent editions of the standards indicated below. Is No 38T, 1970-45, 2, /, 231-6 Part 3, 1963 3812, Part I, 2003 8112, 1989 9103, 1999 Title Specification for Coarse and Fine Aggregates from Natural Sources for Concrete, Second Revisions Code of Practice for Plain and Reinforced Concrete Effortly Revision, Methods of Test. For Aggregarks Felt Concrete Parry 3 Specific Gravity, DCNSITY. Voids, Absorbed Ion and Dehulking Specification for Pulverized Fuel Ash, Part I for use as pozzolan in cement, cement mortar, and concrete, Second Rel I.il, Specification for 43 grade ordinary Portland cement, First Revision Specification for Admixtures for concrete, GRST Revision, 3 Data for Mix Proportioning 3.1 The following data are required for mix proportioning of a particular grade of concrete: A. Grade designation, H. Type of cement, C. Maximum nominal size of aggregate, D. Minimum cement content, E. Maximum water cement ratio, F. Workability, G. EXP Azure conditions as per Table 4 and Table 5 of IS T56, H. Maximum temperature of concrete at the time of placing, J. Method of transporting and placing, K. Early age STRA and GTH requirements, if required, I. Type of aggregate, M. Maximum cement content, and 2. Whether an admixture shall or shall not LX used and the type of admixture and THE condominiumation of USC. 3.2 Target strength for mix proportioning in order that not more than the specified purport ion of test results are likely to fall below the characteristic strength. The concrete mix has to be proportioned for higher target mean compressive EE strength J. The margin over characteristic strength is given H, IHE following relation, FEK equals FK plus 1.65 s, where I target mean compressive strength at 2 LIDAYS in n/RNM, I, characteristic compressive strength at 2x days in n/mm2, and SSTA and deviation n/mm2 3.2.1 standard deviation. The standard deviate ion for each grade of concrete shall be calculated separately. 3,2.1.1 standard deviation based on test strength 11 sample A, number of test results of samples, the total number of test strength of samples required to constitute an acceptable record for calculation of STA and deviation shall he not less than 30, attempts should be made to is 10,262, 2009. Obtain the 30 samples, taken from site, as early as possible. When a mix is used for the first time. B. In case of significant changes in concrete, when significant changes are made in the production of concrete batches, for example changes in the materials used, mix proportioning, equipment or technical control, the standard deviation value shall be separately calculated for such batches of concrete. C. Standard deviation to be brought up to date. The calculation of the standard deviation shall be brought up to date after every change of mix proportioning. 3.2.1.2 Assumed standard deviation. Where sufficient test results for a particular grade of concrete are not available, the value of standard deviation given in Table I may be assumed for the proportioning of mix in the first instance. As soon as the results of samples are available, actual calculated standard deviation shall be used and the mix proportioned properly. However, when adequate past records for a similar grade exist and justify to the designer a value of standard deviation different from that shown in Table I, it shall be permissible to use that value. Table 1 Assumed standard deviation, clauses 3.2.1.2 A3 and B3, SI grade of assumed standard deviation no. Concrete NTMM, I, 2, 3, I, MTO 3.52, M15-3, M204, M254.0 V, 6, MM33507, M408, M455.09, M50X, M55. Note, the above values correspond to the site control having proper storage of cement, weigh batching of all materials, controlled addition of water, regular checking of all materials, aggregate grading and moisture content, and periodical checking of workability and strength. Where there is deviation from the above values given in the above table shall be increased by INTMM. 4. Selection of mix proportions 4.1 Selection of water-cement ratio. So note, different cements, supplementary cementitious materials and aggregates of different maximum size, grading, surface texture, shape and other characteristics may produce concretes of different compressive strength for the same free water-cement ratio. Therefore, the relationship between strength and free water-cement ratio should preferably be established for the materials actually to be used. In the absence of such data, the preliminary free water-cement ratio, by mass, corresponding to the target strength at 28 days may be selected from the established relationship, if available. Otherwise, the water-cement ratio given in Table 5 of is 456 for respective environment exposure conditions may be used as starting point. Note, the supplementary cementitious materials, that is, mineral admixtures, shall also be considered in water-cement ratio calculations in accordance with Table 5 of is 456. 4.1.1 The free water-cement ratio selected according to 4.1 should be checked against the limiting water-cement ratio for the requirements of durability and the lower of the two values adopted. 4.2 Selection of water content. The water content of concrete is influenced by a number of factors, such as aggregate size, aggregate shape, aggregate texture, workability, water-cement ratio, cement, and other supplementary cementitious material type and content, chemical admixture and environmental conditions. An increase in aggregate size, a reduction in water-cement ratio and slump, and use of rounded aggregate and water-reducing admixtures will reduce the water demand. On the other hand, increased temperature, cement content, slump, water-cement ratio, aggregate angularity, and a decrease in the proportion of the coarse aggregate to fine aggregate will increase water demand. The quantity of maximum mixing water per unit volume of concrete may be determined from Table 2. The water content in Table 2 is for angular coarse aggregate and for 25 to 50 mm slump range. The water estimate in Table 2 can be reduced by approximately 10 kg for subangular aggregates, 20 kg for gravel with some crushed particles and 25 kg for rounded gravel to produce same workability. For the desired workability, other than 25 to 50 mm slump range, the required water content may be established by trial or an increase by about 3% for every additional 25 mm slump, or alternatively by use of chemical admixtures conforming to IS 9103. This illustrates the need for trial batch testing of local materials, as each aggregate source is different and can influence concrete properties differently. Water-reducing admixtures or superplasticizing admixtures usually decrease water content by 5 to 10% and 2 is 10,262, 2009 20% and above respectively at appropriate dosages. Table 2 Maximum water content per cubic meter of concrete for nominal maximum size of aggregate, clauses 4.2. A5 and B5, SI nominal maximum no. Size of aggregate TEMM, I, 2, maximum water content I, kg, 3, I, 10,208 2, 20,186 3, 40,165 Note, these quantities of mixing water are for use in computing cementitious material content for trial batch S to water LC content corresponding G to SA turreted S surface dry aggregate. Cement ratio and strength properties of concrete are consistent with the recommendations of IS 456 and meet project specification requirements as applicable. Table 3 Volume of coarse aggregate per unit volume of total aggregate for different zones of fine aggregate, clauses 4.4, A7 and B7, SI nominal volume of coarse aggregate per unit no. Maximum volume of total aggregate for size of different zones of fine aggregate RAM Zone 4 Zone 3 Zone 2 Zone I, 2, 3, 4, 5, 6, 10 2, 23, 40 0.50 0.48 0.46 0.440 66 0.64 0.62 0.60 0.75 0.73 0.71 0.69 Volumes are based on aggregates in saturated surface dry condition. 4.3 Calculation of cementitious material content. The cement and supplementary cementitious material content per unit volume of concrete may be calculated from the free water-cement ratio, C 4.1, and the quantity of water per unit volume of concrete. The cementitious material content so calculated shall be checked against the minimum content for the requirements of durability and greater of the two values adopted. The maximum cement content shall be in accordance with IS 456. 4.4 Estimation of coarse aggregate proportion. Aggregates of essentially the same nominal maximum size, type, and grading will produce concrete of satisfactory workability when a given volume of coarse aggregate per unit volume of total aggregate is used. Approximate values for this aggregate volume are given in Table 3 for a water-cement ratio of 0.5, which may be suitably adjusted for other water-cement ratios. It can be seen that for equal workability, the volume of coarse aggregate in a unit volume of concrete is dependent only on its nominal maximum size and grading zone of fine aggregate. Differences in the amount of mortar required for workability with different aggregates, due to differences in particle shape and grading, are compensated for automatically by differences in rad void content. 4.4.1 For more workable concrete mixes, which is sometimes required when placement is by pump or when the concrete is required to be worked around congested reinforcing steel, it may be desirable to reduce the estimated coarse aggregate content determined using Table 3 up to 10%. However, caution shall be exercised to assure that the resulting slump, water 4.5 combination of different coarse aggregate fractions, the QRS aggregate used shall conform to IS 383. Coarse aggregates of different sizes may be combined in suitable proportions so as to result in an overall grading conforming to Table 2 of IS 383 for particular nominal maximum size of aggregate. 4.6 Estimation of fine aggregate proportion. With the completion of procedure given in 4.4, all the ingredients have been estimated except the coarse and fine aggregate content. These quantities are determined by finding out the absolute volume of cementitious material, water, and the chemical admixture, by dividing their mass by their respective specific gravity, multiplying by 3000 and subtracting the result of their summation from unit volume. The values so obtained are divided into coarse and fine aggregate fract ions by volume in accordance with coarse aggregate proportion already determined in 4.4. The coarse and fine aggregate contents are then determined by multiplying with their respective specific gravities and multiplying by 1000. 5 Trial mixes. The calculated mix proportions shall be checked by means of trial batches. Workability of the trial mix No. shall be measured. The mix shall be carefully observed for freedom from segregation and bleeding and its finishing properties. If the measured workability of trial mix No. is different from the stipulated value, the water and/or admixture content shall be adjusted suitably. With 3 is 10,262, 2009. This adjustment, the mix proportion SHLL be recalculated keeping the free water cement ratio at the pre-selected value, which will comprehend SE trial mix number 2. In addition, 2 more trial mixes number 3 and 4 shall be made with the water content same as trial mix number 2 and varying the free water cement ratio by plus or minus 10% of the pre-selected value. Mix number 2 to 4 normally provides sufficient information, including the relationship between compressive strength and water cement ratio, from which the mix proportions for field trials may be arrived at. The concrete for field trials shall be produced by methods of actual concrete production. 6 Illustrative examples. An illustrative example of concrete mix proportioning is given in Annex A. Another illustrative example of mix proportioning of concrete using fly ash is given in Annex B. These examples are merely illustrative to explain the procedure, and the actual mix proportioning shall be based on trial batches with the given material S. Annex A, Clause 6. Illustrative example on concrete mix proportioning AO. An example illustrating the mix proportioning for a concrete of M40 grade is given in AI to ALL. AI stipulations for proportioning A, grade designation B, type of cement C, maximum nominal size of aggregate D, minimum cement content E, maximum water cement ratio F, workability G, exposure condition H, method of concrete placing J, degree of supervision K, type of aggregate M, maximum cement content N, chemical admixture type A2 test data for materials A, cement used B, specific gravity of cement C, chemical admixture D, specific gravity of I, coarse aggregate 2, fine aggregate E, water. Absorption, I, coarse aggregate 2, fine aggregate M40 OPC 43 grade conforming to is 8112 20 mm 320 kg M 0.45 100 mm, slump, severe, for reinforced concrete, pumping good crushed angular aggregate 450 kg RN. Superplasticizer OP 43 grade conforming to is 8112 3.15 superplasticizer conforming to is 9103 2.74 2.74 0.5% 1.0% 4 is 10262 2009 F, free, surface, moisture, 1, coarse aggregate 2, fine aggregate G, sieve analysis, I, coarse aggregate 2, fine aggregate nil, absorbed moisture also nil. Nil is analysis of percentage of different remarks sieve coarse fraction sizes aggregate fraction -a -ri2 I60 a/2 combined 40 100% 20 100 160 40 10 0. 71.20028.54.75 9043.72.360 conforming to Table 2 of is 383 conforming to grading zone I of Table 4 of is 383 A3 target strength for mix proportioning FCK equals FCK plus 1.65 S where FCK equals target average compressive strength at 28 days, FCK equals characteristic compressive strength at 28 days, and equals S standard deviation. Equals from Table I, standard deviation, S5n/mm2 equals therefore, target strength 40 plus 1.65 x 5 48.25 n/mm2 A4 selection of water cement ratio from Table 5 of is 456, maximum water cement ratio equals 0.45. Based on experience, adopt water cement ratio as 0.40, 0.40, 0.45, hence OK. A5 selection of water content equals from Table 2, maximum water content 186 liter, 425 to 50 mm slump range, 420 mm aggregate equals estimated water content for 100 mm slump 186 plus x 186 100 equals 197 liter. As superplasticizer is used, the water content can be reduced up 20% and above. Based on trials with superplasticizer, water content reduction of 29% has been achieved. Hence, the arrived water content 197 x 0.71 140 liter. A6 calculation of cement content water cement ratio equals 0.40 cement content equals 140 equals 350 kg/m0040 from Table 5 of is 456. Minimum cement equals content for severe exposure condition 320 kg/m3 350 kg/m3 320 kg/m3, hence, OK5 is 10,262, 2009 A7 proportion of volume of coarse aggregate and fine aggregate content from Table 3. Volume of coarse aggregate corresponding to 20 mm size aggregate and fine aggregate, Zone I, equals for water cement ratio of 0.50 0.60. In the present case water cement ratio is 0.40. Therefore, volume of coarse aggregate is required to be increased to decrease the fine aggregate content. As the water cement ratio is lower by 0.10, the proportion of volume of coarse aggregate is increased by 0.02, at the rate of /plus 0.01 for every plus or minus 0.05 change in water cement ratio. Therefore, corrected proportion of volume of coarse aggregate for the water cement ratio of 0.40 equals 0.62. Note, in case the coarse aggregate is NOI angular 1. Then also volume of coarse aggregate may be required 10 be increased suitably, based on experience. For pumpable concrete these values should be reduced by 10%. Therefore, volume of coarse aggregate equals 0.62 x 0.9 equals 0.56. Volume of fine aggregate content I, 0.56 0.44. A8 mix calculations. The mix calculations per unit volume of concrete shall be as follows: A. Volume of concrete. B. Volume of cement equals mass of cement xi, specific gravity of cement I000 C, volume of water equals minus 35 to 0 xi, 3.15 1000 equals 0.111 ml mass of water I equals specific gravity of water x 1000 equals -140 xi I 1000 equals 0.140 mjd, volume of chemical admixture equals, superplasticizer, at 2.0% by mass of cementitious material, mass of chemical admixture I specific gravity of admixture xi000. -7 xi1. I45 1000 E, volume of all in aggregate T, mass of coarse aggregate G, mass of fine aggregate equals 0.006 mj equals A, B plus C plus D, equals 1, 0.111 plus 0.140 plus 0.006 equals 0.743 cubic meters equals Ex volume of coarse aggregate X specific gravity of coarse aggregate Xi000 equals 0.743 x 0.56 x 2.74 x 1000 equals 1140 kg equals Ex volume of fine aggregate X specific gravity of fine aggregate X 1000 equals 0.743 x 0.44 x 2.74 x I000 equals 896 kilograms. 6 is 10,262, 2009. A9 mix proportions for trial number 1 cement water fine aggregate coarse aggregate. Chemical admixture water cement ratio equals 350 kg/m. Equals 140 kg/m. 896 kg/m I 140 kg/Rn equals 7 kg/m equals 0.4. Note, aggregates should be used in saturated surface dry condition. If otherwise, when computing the requirement of mixing water, allowance shall be made for the free surface moisture contributed by the fine and coarse aggregates. On the other hand, if the aggregates are dry, the amount of mixing water should be increased by an amount equal to the moisture likely to be absorbed by the aggregates. Necessary adjustments are also required to be made in mass of aggregates. The surface water and percent water absorption of aggregates shall be determined according to IS 2386. AI0 The slump shall be measured and the water content and dosage of admixture shall be adjusted for achieving the required slump based on trial, if required. The mix proportions shall be reworked for the actual water content and checked for durability requirements. ALL2 more trials having variation of plus or minus 10% of water cement ratio in AI0 shall be carried out and a graph between 3 water cement ratios and their corresponding strengths shall be plotted to work out the mix proportions for the given target strength for field trials. However, durability requirement shall be met. Annex, Clause 6, Illustrative example of mix proportioning of concrete, using fly ash as part replacement of OPC, BO. An example illustrating the mix proportioning for a concrete of M40 grade using fly ash is given B1 to B11. B1 stipulations for proportioning: A, grade designation; B, type of cement; C, type of mineral admixture; D, maximum nominal size of aggregate; E, minimum cement content; F, maximum water cement ratio, workability; H, exposure condition; J, method of concrete placing; K, degree of supervision; M, type of aggregate; N, maximum cement; OPC, content; P, chemical admixture type; M40 OPC 43 grade conforming to IS 8112; fly ash conforming to IS 38I2, part I, 20 mm 320 kg/m 0.45 100 mm, slump, severe. 4. Reinforced concrete, pumping good crushed angular aggregate 450 kg/m superplasticizer. 7 is 10,262, 2009. 8-2 test data for materials: A, cement used; B, specific gravity of cement; C, fly ash; D, specific gravity of fly ash; E, chemical admixture; F, specific gravity of I, coarse aggregate; 2, fine aggregate; G, water absorption; 1, coarse aggregate; 2, fine aggregate; H, free surface moisture; 1, coarse aggregate; 2, fine aggregate; J, sieve analysis; I, coarse aggregate; 2, fine aggregate. OPC 43 grade conforming to IS 8112. 3.15 conforming to IS 3812, part I, 2.2 superplasticizer conforming to IS 9103. 2.74 0.5%. 1.0% nil, absorbed moisture also nil. Nil is analysis of percentage of different remarks. Sieve coarse fraction sizes aggregate fraction -A-. RI 260A2 combined 40 100% 20 100 160 10 0 71.200 4.75 9.40 2.360 40 28.5 3.7 128.5 3.7 conforming to Table 2 of IS 383 conforming to grading Zone I of Table 4 of IS 383 8 to 3 target strength for mix proportioning RET equals let plus 1.65 s where equals RET target average compressive strength at 28 days, FK equals characteristics compressive strength at 28 days, and equals S standard deviation. From Table I, standard deviation, S equals 5n/mm2. Therefore, target strength equals 40 plus 1.65 x 5 equals 48.25 n/mm2. 8:4 Selection of water cement ratio from Table 5 of IS 456, maximum water cement ratio, see note under 4.1, equals 0.45. Based on experience, adopt water cement ratio as 0.40, 0.40, 0.45, hence, OK 8:5 Selection of water content from Table 2. Maximum water content for 20 mm aggregate equals 186 liter, for 25 to 50 mm slump range, estimated water content for 100 mm slump equals 186 plus x 186 equals 197 liter 108 is 10,262, 2009 as superplasticize ECR is used. The water content CAN he reduced up 10%. Based on trial S with superplay STI sizer WATER content reduction OF2% has been achieved, hence, the arrived what ER content equals 1 LL7x 0.71 equals 140 liters. 8:6 Calculation of cement and fly ash content water cement ratio see note under 4.1, equals 0.40 Cementitious material, cement plus fly ash, content from Table 5 of IS 456, minimum cement content for severe exposure condition S 350 kg/m. 320 kg/RRR, hence. OK 140 minus 0.40 equals 50 kg/m equals now, to proportion a mix containing fly ash the following steps are suggested. A. Decide the percentage fly ash to be used based on Proj CT requirement and quality of materials. B. In certain situations increase in cementitious material content may be warranted. The decision on increase in cementitious material content and its percentage may be based on experience and real.iu note, th is illustrative example is with increase of 10% cement. Cementitious material content. Cementitious material content water content equals 350 x 1.10 equals 3R5 kg/m equals 140 kg/m so. Water cement ratio equals 1.364 385 equals fly ash at 30% of total cementitious material content 385 x 30% 115 kg/rn cement, OPC, equals 385 to 115 270 kg/m saving offacement while using fly ash being utilized equals 350 to 270 equals 80 kg/m, and equals / 5 kg FMB 7 proportion of volume of coarse aggregate and fine aggregate content from Table 3 volume of coarse aggregate corresponding to 20 mm size aggregate and fine aggregate, Zone I, equals for water cement ratio of 0.50 0.60. In the present case water cement ratio is 0.40. Therefore, volume of coarse aggregate is required, 0 be increased to decrease the line aggregate content. As the water cement ratio is lower high 0.10. The proportion of volume of coarse aggregate is increased by 0.02, at the rate of / plus 0.01 for every plus or minus 0.05 change in water cement ratio, therefore. Corrected proportion of volume of coarse aggregate for the water cement ratio of 0.40 equals 0.62. Note, in case the coarse aggregate is not angular 1. Then also volume of coarse aggregate may be required to be increased suitably. Based on experience. For pumpable concrete these values should be reduced by 10%. Therefore. Volume of coarse aggregate 0.62 x 0.90.56. Volume of fine aggregate content equals I, 0.56 equals 0.44. B8 Mix calculations. The mix calculations per unit volume of concrete shall be as follows. A. Volume of concrete equals 1 mjb. Volume of cement equals mass of cement Ix. Specific gravity of cement I0009 is 10,262, 2009 c. Volume of fly ash D. Volume of water minus 27 to 0 xi, 3.15 1000 0.086 rrr. Mass of fly ash x. Specific gravity of fly ash. Gu equals minus 115 x to 1000 equals 0.052 nr equals mass s of water x. I. Specific gravity of water 1000-140 x to 1000 equals 0.140 mje. Volume of chemical admixture, superplasticizer, at 2.0% by mass of cementitious material, equals mass of admixture xi. Specific gravity of admixture I000 f. Volume of all in aggregate G, mass of coarse aggregate H, mass of fine aggregate equals 7xi1/45 1000 equals 0.007 mj equals A. B plus C plus D plus EJ equals 1, 0.086 plus 0.052 plus 0.140 plus 0.007, equals 0.715 mj equals Ix. Volume of coarse aggregate X. Specific gravity of coarse aggregate Xi000 equals 0.715 x 0.56 x 2.74. 000. 1097 kg equals Fx. Volume of fine aggregate X. Specific gravity OF. Fine aggregate X 1000 equals 0.715 x 0.44 x 2.74 xi000 equals 862 kg. B9 Mix proportions for trial number 1. Cement. Aryash water fine aggregate core Se aggregate chemical admixture water cement rat io, set note under 4.1. Equals 270 kg/m equals 115 kg/m equals 140 kg/m equals 862 kg/m equals 197 kg/rn equals 7.7 kg/rn equals 0.164. Note, aggregate ES should be used in saturated surface dry condition. If otherwise SE. Hen computing the requirement of mixing wafer. Allowance shall he made for the free, surface, moisture contributed by the fine and coarse aggregates. On TB other hand. If the 10 is 10,262, 2009 aggregates are dry. The amount of mixing what show ULD he increased by an AUUMT1 UALI2 the new upture ILL3B of HDBIH. Aggregates. Necessary adjective Ustmanson, although required to be made in MOS SUFAG.GN, 3 TTS the surface water and %TAI, IABS or pion of aggregate S shall be determined according to is 21 MB, Pan 1. B10 the S lump shall he may assure to ND the water content and dosage of admixture shall be adjusted for achieving the required S lump based on TREL. If required, the mix proportions shall he reworked for the actual water content and C hect FOR dilubility requirements. B11 Two more trials having variation of plus or minus 10% of water cement ratio in BIO shall be carried out and a graph between 3 water cement ratios and their corresponding strengths shall he plotted to work out the mix proportions for the given target strength and GTH for field trials. However, durability requirement shall he met. Annex. Forward, Committee Composition Cement and Concrete Sectional Committee, CEO2 Organization RPR UNROT IL, L. Delhi Tourism and Transportation Development Corporation Ltd. New Delhi ACC Ltd, Mumbai Atomic Energy Regulatory Board, Mumbai Building Materials and Technology Promotion Council IL. New Delhi Cement Corporation of India Limited. New Delhi Cement Manufacturers Association. Noida Central Board of Regulation and Power. New Delhi Central Building Research Institute, CSIR. Roorkee Central Public Works Department, New Delhi SHRJ Jos Eki Irian, Chairman, Shri Navula Wanchaldla Shri P. Srinivasan, Aflunal, DRPRAHRCB Ashore LR. Vishnar, Aflani JI Shri JKPRA, comma dash dot, LCIRR. Ardalziwani 1. CIRE MKACARWA, Alt Malt, SIIREN. MLIR1LLY or SPGOGE, 2 null slash, MINC Cree Jamid Rectlr, Civil. ALU WTT, DRBKRAOSNMISK. AC, Athunlo AI. 2 Una, CMU Ingln ER, OTCU, N, SIIR pound RLLM NIM EC, Inajir, SNS, Mina Central Road Research Institute, CSIR. New Delhi Central Soil and Materials Research Station, New Delhi Central Water Commission. New Delhi Conmal Technologies Pvt Limited Kalkara Construction Industry Development Council. New Delhi Directorate General of Supplies and Disposals, New Delhi Dr Ramkumar Ciri Satanijfrk Limar, 2 Tuna, Shri Murari Raina Shri N Chanlira. L. Cran, 2/new, DTRL Alt, CMDD, N and W, Duiran DRECTOLL, CMDD, NWNS, 2M.L, DRAK. Shatiyu, Silri PR. Swarup Silral Suni El Mahaja 1, MT Mal, Shri VB /I. Line Wame, IIAN Shri R. P. Sinji, Melnal, IASH Utilization Program. Department of Science and Technology. New Delhi Gammon India Limited. Mumbai Grazim Industries Limited, Mumbai Dr Vimal Kumar SHRJ MLIKEI 1 L Malil Jair, alternate, SHMS. A. RF.LM11 Shlu M.U Snail, Mdunel, Shore AK. JN Shore M. C. A. Mawal, MIRNA, 11 is 10,262, 2009 Organizadas Gujarat AMB Cementitious Limited. Ahmedabad Housing and Urban Development Corporation Limited. New Delhi Indian Bureau of Mines. Nagpur Indian Concrete Institute, China Indian Institute of Technology. RO Org CEINDEN Roads Congress. New Delhi Institute for Research, Development and Training of Construction and Trade, Bangalore Institute for Solid Waste Research and Ecological Balan CE. Visakhapatnam Madras Cements Lid. China L1 Illilary Engineer Services, NGNARINC Hypes Branch, Army HQ. New Delhi Ministry of Road Transport and Highways. New Delhi National Council for Cement and Building Materials, Balabgarh National Test House. Kolkata OCL India LI MIT. New Delhi Public Works Depart, NR, Government of Tamil Nadu China RV College of Engineering G Bengal or Research, Design and Standards Organisation, /Tini Streti of Railways. Lucknow Representative S, Silk, 1. P05/1 SMURK, J, I. I/T Alternat CFL, K/T-S and T/.1/2 SFI1N, UIPJ Silk Viakuki. /K, T/Runl CE, Silk SS. Da Silk MRLRLIH /San, /LEOL. CIKE LN. AI2 SL DSKL Ivasas Iahernate, PUSK. KSL who /YGISILAI DLKL.NLLK A/REMLDRN RI JH FNDR DKNBILA LJMAHIIL S citri NK I/I as alter/WLE Shri Vijag S Tila citri BIJUIK1S or YI Ultima TE SHKLJB Shakma Shri YIX2 Sinji I /LI Alternate S Sil Relay and Doimkar S Elikl SK Pearl Alam ULE Sil RIRC Wason DRM M AU AL Remade Shri DK Kanung OSLLKLBR Muana Mlairil Ur DRSCAMLAIIASII KLNNE INLL.K D.SLGN EXI.CT2R alternate SIIRIRM SIL /KL /5 1 VKY / .1 IIRMALR Shanghai Industries Limited Sonai Nagar SHKID2 T R /ODHK I/IAIK L11/EMAS/E SARDAR Saravar Nanadaniga M Limited DISTNA Ramada 0111.1E I K .WAMF ./M SIILKSILILI E A /H.KVLL/Ernade ST Ruktura L Engineering Research Center Xiri C Hen Ni SIRIR CIII.I.I.ANNSLLKL1 IKU /K/R ALRMI/RE THC India Cements Limited China ISITK Skilpasaflo CIRERAKUN /OL /LA ALTE Renade the Indian Allium Pipe Company Limited Mumbai ITBNs Rairu Yuan of Engineer India Kolkata Ultratech Cement Lid Mumbai BIS Directorate General Silk PD Kuke /R Silk SJSII /1T A/EMET DRHCVLSHW /Rhea SLIKL Baller SIGH AL10 Ult Citri SUHKATIL Kwalari CIREAK Sani Scientist FN Head CIVN Representing Director General EX Officio Member Secretary Silky San LW Pani Scientist E and Director C4 His CIRE SIKL and KLMK Scientist STB and Director Sivan L. G. His 12 Concrete Subcommittee, said 2 is 10,262, 2009 Organization Delhi Tourism and Transportation Development Corporation Ltd, New Delhi ACC Limited Mumbai Atomic Energy Regulatory Board Mernbay Building Materials and Technology Promotion Council, New Delhi Central Building Research Institute, CSIR Roorkee Central Public Works Department New Delhi Central Road Research Institute, CSIR New Delhi Central Soil and Materials Research Station New Delhi Central Water Commission, New Delhi Engineers India Limited New Delhi IASH Utilization Program Department of Science and Technology, New Delhi Gammon India Limited Mumbai Grasim Industries Ltd, Mumbai Gujarat Ambuja Cement Limited Ahmedabad Indian Concrete Institute Chennai Indian Institute or Technology, New Delhi Indian Institute of Technology, Kanpur Indian Institute or Technology Roorkee Military Engineer Services, Engineer-in-Chief's Branch Army HQ, New Delhi Ministry or Road Transport and Highways New Delhi National Buildings Construction Corporation Limited New Delhi National Council for Cement and Building Materials Balabgarh National Institute of Technology Warangal Nuclear Power Corporation of India Limited, Mumbai Pidilite Industries Limited, Mumbai RV College of Engineering Banga/or Ready Mixed Concrete Manufacturers Association Bangalore Research Design and Standards Organization, Ministry of Railways Lucknow Shri Ani Banch har shore pbanixlt all hya backslash, A11F7 Iliul dr prayer cbasl shore lr bizian, AIUT1IILU, Shri JK Prasad shore pa slash alguita, A11NWU, DRBK Rao DRSK and ARWAI, AI Anul, Surelu Nlui slash, dot. Engino JT, D1SICJ, LC1. I1VE Inglesit J, D1K, N, 3, AI Einwua, Director Shri Satan Ilful KL Mar, Atumal, Siiri Murari Ratnam Siiri and Chasilra Datsu, Haran, Tomate, DIRL.NLLR, CNMDDL Duel Tai DIRUIOR, CNMDD, AII Mao, Shore ARVINILKL Mar Shri T by Raj, Adumlr, DRV Malkumar Siiri Mukal CIMAHILR, ATLU1LMR, Siiri SAROL DRNKNWAK, AIIMTJI, Siiri AK Lane Shri MC Enrawal, AIINUJ slash, Siiri L. P Desai Shri BK Lajitla, AII Nuld, P of MS Sutai Shore LN Adam, Alt Mao, DRB Bana, Lergia Dr Sulalir Mish A Dr Asail Kuma Jane Brig RK Goi. COLVK Barely.A, Alt Nuld R, C Irf TBB backslash near Ju, Siiri Kamu H Kumar, Alt MTLL, Shri LPSH Shri DAR.Shasinoi, Alt Ru, Siiri RCWA.Sun Shri HKLW.XA, Alunwt, DRCBK backslash TR underscore Swara RI backslash ODRD Reemla SF.SHT, Altimos, Silver J USP Vihilma SHRJPLP11O Shil K Paflulaker, Alt Mao, Prim. TS Nagaraj C Irf VFL backslash YKR Col.J, AR, Joyce D1 RUTOR Sluiels, BNS, LCB1J, FHTD1 RI Pound Roar SLLTLS, BNCI2, A/T Ma, 13 is 10,262, 2009 Okani, L/I, M Structural Engineering Research Center, XRJ, Spenatandon Consultants Private Limited, New Delhi TCE Consulting Engineers Limited. Mumbai Tours Teal Research Foundation in India. New Delhi in personal capacity, 35. Park ANU. Anama. Nuikat Street, Kuniamathur. Coimbatore, in personal capacity, 36. Old Snanagar, WCM/Harod. Nagpur, Representatives Shri T.S. KRISHNAMOOJ Ili SHRJK. Bilasubramanian, Al Ramate, Shri Maheshti Nixeln Shri Vinayaguptailt Muti Shri J. P. Haran Shri S. M. Pal Ekar, Alternate, DRPC Choud Huri DRCS Vishwanathai, Ail Mate, DRC Rayajikumar Shri Lalit K. Umar Jain 14 GMGP 280 bis/ND/2009-1.000 Kopal. Call 1 IL/LD Trom Seco ND, O/ER, proportioning of concrete mixes can he regarded as procedure set to proportion the most economical concrete mix for specified durability and grade for required site conditions. As a guarantor of quality of concrete in the construction, the constructor should carry out mix proportioning and the engineer in charge should approve the mix so proportioned. The method given in this standard is to he regarded as the guidelines only to arrive at an acceptable product, which satisfies the requirements of placement required with development of strength with age and ensures the requirements of durability. This standard does not debar the adoption of any other methods of concrete mix proportioning. In this revision, assistance has also been derived from ACI 211.1, reproved 1997, Standard Practice for Selecting Proportions for Normal, Heavyweight, and Mass Concrete, American Concrete Institute. The composition of the committee responsible for formulation of the standard is given in Annex C. For the purpose of deciding whether a particular requirement of the standard is complied with, the final value, observed or calculated, expressing the result of a test or analysis, shall be rounded off in accordance with IS 2, 1960 rules for rounding off numerical value s, revised. The number of significant places retained in the rounded off value should be the same as that of the specified value in the standard. Bureau of Indian Standards. CIS is a statutory institution established under the Bureau of Indian Standards Act, 1986, 0 promote harmonious development of the activities of standardization, marking and quality certification of goods and attending to connected matters in the country. Copyright CIS has the copyright of all its publications. No part of the SE publications may be reproduced in any form without the prior permission in writing of BIS. This does not preclude the Free USC, in the course of implementing the STANDARD. Of necessary details. SUCHS symbols and SISs, type or grade designations. Inquiries relating to copyright be addressed to the Director, Publications, BIS. Review of Indian standards amendments are issued to standards as the need arises on the basis of comments. Standards are also reviewed periodically. A standard along with amendments is reaffirmed when such review indicates that no changes are needed. If the review indicates that changes are needed, it is taken up for revision. Users of Indian standards should ascertain that they are in possession of the latest amendments or edition by referring to the latest issue of CIS Catalog and Standards, monthly editions. This Indian standard has been developed from Doc No. Sed 2, 7288. Amend No. Amendments issued since publication date of issue text affected headquarters, Bureau of Indian Standards Manak Shavan 09 Bahadur Shah Zafar Marg, New Delhi 110,002 Teleplunks, 2323 on I, 323 3375. 2.N39402 website, www.bis.org.in Regional Offices, Telephone Central Manak Bhavan, 9 Bahadur Shah Zafar Marg New Delhi 110002, 2323 7617 23233841 Eastern Northern 114th CIT Scheme 71/1. VIP Road. Kankuru Ashi Kolkata 70005 to 1 SCO.135.3.16. Sector 34A Chandigarh 160-022, 23378499, 2337 8561, 23378626, 23379120 3843 9285 Southern CIT Campus. 4 Cross Road. Chennai 600, 113, 2254 1216, 2254 144 2225 42519, 2254 2315 Western Manakulaya. Elj Midc Moral. Andheri, East, 1/IU1/1 by -100, 193, 2832 9295, 2800, and 32 7858 28327891.2832 7892 branches, Ahmedabad, Bangalore, Bhopal, I3 Bhubaneswar, Coimbatore, Faridabad, Ghaziabad, Guwahati, Hyderabad, Jaipur, Kanpur, Lucknow, Nagpur, Purwanu, Putna, Pune, Rajkot, Thiruvananthapuram, Visakhapatnam. Printed by the General Manager, Government of India Press, Nashik, 22006.